We are here to talk about how to solve logarithmic equations. So to start off, I want to remind everyone what a logarithm is. So I'm going to put in parentheses here next to logarithm that a log is an exponent. So when I say logarithm or say log, just think it's an exponent. It's an exponent. So here's the definition of log. We would say that y is the log base b of x if and only if b to the y equals x. Now this I'm sure you're more familiar with, so maybe you should look at this and then look at this second. B to the y equals x. So b is the base, y is the exponent, and x is what you get when you raise b to the y power. So if this is true, if this is the relationship between b, y, and x, then we can also say that y, which is the exponent over here, y is the logarithm base b of x. So we are restating the relationship between b, y, and x, just in a different form of equation. B is still the base, y is still the exponent, x is still the result when you raise b to the y power. The only difference is that in this equation, y is isolated. So the logarithmic equation is simply a way to isolate the exponent in this relationship. Okay, these two equations are expressing the same interaction between b, y, and x. Okay, so now that we know the relationship between b, y, and x, at least in this form of equation, we can solve for either y, b, or x if we're given 2 out of the 3 values. There are a couple of restrictions, though, on what b is allowed to be. So in this equation, in the logarithmic equation, b is required to be greater than 0. So in other words, you will never see a b value that is less than 0. Another restriction is that you won't see a b value of 1. You won't see a b value of 1. And the third restriction is x has to be greater than 0. Now, I'm not going to go into explanation in this video why we have these 3 restrictions, except to say that the graph of the logarithmic function, which looks like this, wouldn't look like this if we let b be less than 0 or 1 or x less than 0. So in order to preserve the nature of the logarithmic function, we have these restrictions. Okay, now for some examples of logarithmic equations we can solve. Log base 3 of x equals -4. Okay, I've switched the y around, so -4 is the y value. So as I said before, this is the base. So we are saying through this equation that 3 raised to the y power, so negative 4 power, is x. Okay, 3 to the negative 4 is 1 over 3 to the 4th. So x is 1 over 81. Okay, here comes a second example. So I'm switching the unknown now. And I'm using x exclusively for the whatever the unknown value is, whether it's the base, the exponent, or the other number. Okay, log base 2 of 8 equals x. So this is saying that 2 raised to the x power equals 8. Okay, now some of you may be able to tell from here what the answer is. Maybe you can't. So in the case where you can't, what you want to do is make sure that both sides of the equation have the same base. The base here is 2, the base here is 8. That's not the same. However, 8 can be expressed as base 2 to the third power. So once the two bases are the same on the left and right, you can then equate the exponents. So x must be 3. Okay, here's a third example. Okay, this time the base is the unknown. So the base x, when raised to the 2/3 power, gives 4. Okay, we want to isolate x. However, x has an exponent, so we would like to get rid of the exponent. I'm going to do this in 2 steps. So first I'm going to raise both sides to the 3rd power. And I do that because I know that I'm allowed to multiply these two exponents, the inner one and the outer one. And when I do that, the denominator 3 in this fraction will disappear, leaving x squared, and the right side 64. So now you can see that x is plus or minus 8. However, x is the base. And back earlier, a couple minutes ago, I said that the base has to be greater than 0. So when I initially have 2 answers, I remember that the base can't be less than 0, so I will throw out the negative 8 and keep only the positive 8 as my single solution. Okay, so just a quick wrap up. This is a logarithmic equation which gives you the relationship between b, y, and x, which you can imagine like this. There are 3 restrictions, a couple for b and 1 for x, that you should be aware of. And when you're given a logarithmic equation, best thing to do is put it in exponential form. So base raised to the power equals the result, and then solve for x, whether it be the result, whether it is the exponent, or whether it is the base. And keep in mind, if it is the base must be positive. Okay, thank you, and we'll see you next time.